Hello, today we're doing 10.2 part 2. We're continuing with combinations. Now nothing is different that we did yesterday. The only difference is now I'm going to do word problems where you might have factorial, you might have permutations, you might have combinations, and then you might have adding or multiplying with the combination. So every problem is going to be a little bit different. So this is just going to be practice. Okay, so let's go ahead and get started. This year's student council has 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. How many different ways are there to choose a committee with 2 seniors and 2 juniors? Now, if we think about choosing a committee, does order matter? No, just 2 seniors, 2 juniors. It doesn't matter which was the first senior I chose or the first junior. So this is definitely a combinations problem. Okay, so we're going to choose 2 seniors and 2 juniors. So 2 seniors out of how many seniors I have, which is 6. So we're going to choose 2 of those 6. And remember what I told you to do? We write at the top of our papers, and is multiplication, and or is addition. And we're going to choose 2 juniors. There's 5 possible juniors. Go ahead, take a minute to put this in your calculator, and you will get 150. Okay, next problem. How many different committees of at most 4 students can be chosen? Now this time, we don't care about how many seniors, juniors, sophomores, or freshmen we have, okay? We only care that we're choosing at most 4. So let's talk about this. We can choose 4 of the 18 total. How do I know there's 18? 6 plus 5 plus 4 plus 3, okay? Or we can choose 3 of those 18 students. Or we can choose 2 of those 18 students. Or we can choose 1. Now, can we choose 0? This one's a little bit tricky because can you have a committee with nobody on it? No. So this one, there's no 0 because that would mean no people. So I'm leaving 0 off of this. So sometimes on these problems, I do like to go ahead and do them separate on my calculator. It's just my choice. Like I would find out that this was 3,060. This is 816. This is 153. This is 18. Then I would add them all up. It's fine if you type it all in. You just have to be careful that you don't miss something, because if you do all this work and you just forget one of those on your calculator, then you'll have the wrong answer. Okay, so let's go ahead and try the next problem. For the Millennium Elementary Reading Program, parents must read 4 stories to their children. They can choose between reading 5 fiction or 5 nonfiction stories to their children. So those are our options, 10 total. We have 10 total stories, and they have to choose 4 of those. If the order in which the parents read the book to their child is not important, how many different sets of 4 books can they choose? So very simple. We have 10 total stories. We're going to choose 4 of those. We don't care about the order. Done. The answer is 210. Part 2, in how many groups of 4 books are all of the books either fiction or non-fiction? Okay, well, if we're choosing 4 of those books and maybe we want to read all non-fiction, we would choose 4 of those 5. Or we can choose 4 of those 5 fiction. You get 10. Okay? Now, last question. If the order in which the stories were read did matter, in how many different orders could the 4 stories be read? So this time I care about order, but I'm still choosing 4 of 10. So this is a P problem. 10P4 would give me 5,040. Many more different possibilities than in Part A, where we only had 210 options. That's because in this case it does matter the order we read them. So you kind of recognize the difference. This was pretty obvious because I wrote did matter, order did matter, and I say in the Part A order does not matter, but we're just going to get used to it and keep practicing these type of problems. Okay, next example. You're at a party that has 6 types of cookies and 6 types of cakes. You're choosing to eat your 3 favorite desserts. How many combinations of desserts can you eat? Well, let's take a look. First, I can see that there are 12 total possibilities. I'm just choosing 3 of them. Order doesn't matter, so I'm going to choose 3 of my 12. When I do that, I get 220. You might get full before eating 3 desserts. In how many ways can you eat at most 3 desserts? It was kind of like that committee problem in yesterday's notes when we're talking about at least 4 people, or at most 4 people on the committee. Okay, so I can choose to go ahead and eat 3 desserts. I'm going to choose 3 of those 12. I can go ahead and choose to eat 2 of those desserts. Or I can go ahead and choose to eat 1 dessert. Now in this case, does it make sense to have 0? Yeah, I can have 0 desserts. What if I'm too full from dinner? I can't eat any of those 12 desserts. So in this case, it is okay. 0 does work. So this would be 220. This would be 66. This would be 12. This would be 1. I add them all up and I get 299. Okay, last possibility, or last question. You want to taste all 12 desserts and eat them in order from best to worst. How many different arrangements are there? When I'm talking about arranging all of my possibilities, I have 12 desserts. I'm going to taste all 12 desserts. All it is, 12 factorial. So remember, factorial means arrangement. 479 million. No. Yes. 1,600. There we go. Now, I expect everyone try this. You try on their own. Okay? I want you to look at the 2 examples that I just did, see which is comparable. I want everybody to walk in with an equation and an answer for all 3 of these parts. Any questions, comments, or concerns, go ahead right at the bottom of the paper, and I will see you tomorrow in class.